So our activity is all from.
Is it more than a page?
It's rough. No, it will not fit on your patty paper. So we're in section 1.6, and what we're talking about is transformations. The activities we did 3 different transformations. Our first activity was what we call a translation. So our first activity was called a translation. When we do a translation, every point moves the same distance in a straight line. So our first activity, when we slid our patty paper along that line, that's how we made sure that we moved in a straight line, and then we stopped and we retraced our figure. So when our new figure had moved whatever distance we moved the patty paper in a straight line. So our first activity was called a translation. The second one, what would you guess the second one was called? Where we held our point on and rotation. Number 2 is called a rotation. So that's our second transformation. So in our first one, every point moved through in a straight line, the same distance. What did we decide in the second one? Our points move through what? When we rotate, what are we changing? What did you say, Evangelique? The angle. So in a rotation, each point moves through the same angle. And the point that we rotate around is called the center of rotation. So the point that we held our pencil on was our center of rotation, and we rotated our patty paper through an angle, and then we redrew our figure. So our second, we had a translation. Every point moves the same distance in a line. Second one, we move around the center of rotation through the same angle. And our third one, we said was called what? When our point went across the line? A reflection. Our third transformation was a reflection. And on a reflection, each point moves across a line. And what would you guess we call that line if we're talking about a reflection? What do we look at our reflections in normally? A mirror. So we call that line the mirror line. And when we said that angle looked like it was 90 degrees and the segment between the points was cut in half, what that tells us, and we'll talk more about this term later, the mirror line is the perpendicular bisector and perpendicular bisector just means 90 degrees cut in half. So it made a 90 degree angle with the segment, and it cut that segment in half. It was a perpendicular bisector of the segment between the points. So the mirror line cuts that segment in half and it makes a 90 degree angle with it. So our three transformations that we did today are a translation, a rotation, and a reflection. These three transformations have a special name. We call these the rigid transformations. And the reason we call them rigid is that they don't change the size or the shape of our object. So we call these rigid transformations. The three that we just did, translation, rotation, reflection, are rigid transformations. The image that we start with, the figure that we start with, is called the pre-image. And after the transformation, we call it the image. So in your homework, it'll talk about the pre-image and the image. So I just want you to understand the pre-image means the thing before it gets transformed. The image is what happens after it's transformed. And we said that the size and the shape of the image and the pre-image were the same. So the image and the pre-image are congruent. So with these three transformations, translation, rotation, reflection, the image and the pre-image are always congruent. And this leads us to our definition. The way we described congruent was same size and shape, and I said we were going to make it a little more precise. With these three transformations, this is how we make our definition of congruence a little more precise. So we're going to say now that we're going to define congruent by saying that two objects are congruent when one is a rigid transformation of the other. So this is how we're going to tell if, this is the technical way we tell if things are the same size and shape. if we can take the pre-image, we can translate it, we can rotate it, and we can reflect it in some way so that it's right on top of the image and they're exactly the same. That's how we tell if they're congruent. So if we can do some combination of rigid transformations to get from the pre-image to the image, that's how we know when things are congruent. So the way we tell if angles are the same shape, same size and shape, is if we can take one angle, we can slide it around, we can rotate it, we can flip it over and set it right down on top of the second angle, and they exactly match. That's how we tell that they're congruent. We can take two triangles, translate one, slide it around, rotate it, flip it over so it sits right on top of the second one. That's how we tell that they're congruent. So that's what we mean by same size and same shape, is that we can do some kind of rigid transformations to one and get to the other. So that's our technical definition now of congruent. Is two objects are congruent if one is a rigid transformation, and it could be any combination of the rigid transformations. Translation, rotation, reflection. One is the transformation of the other, a rigid transformation of the other. So that's our technical definition of congruent. Questions? All right. That's all the notes for today.